All right, so let's look at lesson 2 on significant figures that you covered. Is there any questions you have on what was covered in the video as far as significant figures go? Significant figure rules or anything like that? You want to talk about, discuss? Go ahead, Luke.
Just like the decimal places, the zeros before are not significant. Okay,
so let's look at an example and look at that. So if you have 0.00246 centimeters, okay? Zeros, anytime zeros come at the beginning of any non-zero digit, like this 2 is a non-zero digit, these zeros will never be considered significant digits. As long as there's no decimal point. Okay? So let's focus on one thing at a time, but yes. So these zeros, everyone understand, are never ever going to be significant, no matter what. Okay? So often we use the term scientific notation, and you've probably, I'm hoping by now, you've learned how to do scientific notations. So in scientific notations, we would drop these zeros because they're just placeholders, and we would end up writing our answer as 2.46 times 10 to the negative third, right? Centimeters, okay? And so in scientific notations, we only write the digits that are significant. So your math teachers, when they taught you scientific notations, they weren't really clear why you were dropping zeros, but essentially what they were trying to do is set you up for understanding significant figures. You drop any zero that is not significant. If it's just a placeholder to give us an indication of where our first significant figure is in our measurement, then they're just placeholder zeros. Okay? Clear on that? Okay, so here's another, oh, go ahead. So 3605. That one? Something like that. Okay. They are. That is because every digit that is a non-zero, if it's represented, written as it is on your paper, they are always significant. Zeros that are sandwiched, I call them sandwich zeros, because they're sandwiched in between non-zero digits. They're always significant too. Okay, so all 4 of these are significant, and so you have 4 sig figs here, whereas you only have 3 sig figs here. Okay. Okay, so let's do that. Say 360500. Is that what you're asking? Okay, and then you have a point and another 0. Good? Okay, now, this might be the toughest rule out of them all, okay? So, obviously, those are significant still, right? Those haven't changed. The question is, are these trailing zeros at the end of the number significant? The answer is yes. Only because there is a decimal point indicated in the measurement. Okay?
So that's just meaning that the one that's estimated is the one after the decimal point.
That is correct. That is the estimated digit. Okay? Just like in any measurement, the last digit is your estimated digit. Okay? So in this case, we would include these zeros being significant, and we would say we have 1, 2, 3, 4, 5, 6, 7 sig figs. Okay? With that 0 being the estimated digit. Okay? That means the rest of them are certain. Okay? That's one big giant ruler. Okay?
adding numbers and like one has 4 digits, one has
Okay,
and one has.
can we table that question for just a moment? I am going to answer that question, I promise you. I'm going to get there. I'm going to go over addition, subtraction, multiplication, division with you in just a moment, okay? So we'll get there, okay? I promise you. All right, let me give you another example. If I had the same 3605000, are these zeros now significant?
No.
No. Zeros that trail and there's no decimal place at all are not significant.
75.00 is both the zeros at the decimal place significant or just the first?
Let's do that. So 75 and then just 00.
0.0.
0.00. Okay. Is there a decimal place?
Yeah.
It's represented. Those are significant.
Okay. So every.
Okay. It doesn't matter where the decimal place is located at. If there's any decimal place indicated, zeros at the end have to be significant.
What about like 75.00?
Okay, so 75.0206.
Sure.
Is that what you're saying? Okay.
So that's 0.
Well, first of all, both of these zeros are what? Sandwiched. Right? If they're a sandwiched zero between non-zero digits, they will always be significant. So these zeros are significant, and all of the other non-zero numbers are significant. So 10, if it is just like this, there's one significant digit. What it tells us is that this is our estimated digit, and the 0 is just a placeholder. It tells us that we know that we're guessing that it's around 10. We're thinking it's around 10. So our guess or estimated digit is in the tens place, okay? But if I add a decimal point following that 0, what does that tell us now about that 0? It's significant. So we went from one significant figure to now 2, which means the 1 is a certain digit and the 0 is the estimated digit now.
And then in order to write it correctly, we have to put 0.
No. If you put a 0 after the decimal place, you just changed your whole meaning, right? Because now we're saying we know that these two digits are certain, and that becomes our estimated digit. So if that's your estimated digit, do not put another 0 behind it. Okay? Once you hit your estimated digit, don't add any more digits after the first estimated digit. Okay? So there is a difference between 10 and 10.0. All right?
If it was 10.0, would we do 3 digits instead of 2?
Like that? Yes. There would be 3 significant digits now. Okay? Again, with that last 0 being the estimated digit. Yay? Okay, let me give you another one. And it's okay that this might take some time for us to really process. It may take several weeks. So don't worry. Okay, we'll practice and practice. So if I have a 0.0260, okay, are these zeros significant? No. Why are they not significant? Because they become before the first non-zero digit. So no matter what, they will never be significant. The 2 is significant. The 6 is significant, but what about that 0? What do you think? Again, this is the hardest one. Is there a decimal place? Right here.
Oh, right there.
there is a decimal point. Because there's a decimal point in the problem or in the answer, that 0 has to be significant. These are not, but that 0 is. That's probably one of the hardest things to start getting your head around, okay? Anytime a decimal point is indicated in the measurement, that 0 is significant, okay? Now, follow scientific method or scientific notation rules, because if I was to put this in scientific notations, it would be 2.60, because that's significant, times 10 to the minus 2. Now, notice there's a decimal point always in scientific notations. And the decimal point will always come after that first non-zero digit, okay? So trailing zeros are significant still because of that decimal point, okay? That's why scientific notations was put together in the first place, to indicate significant digits and drop down all non-zeros that are just placeholders, okay? Clear? Okay. So in chemistry and physics, we often like to use scientific notations, okay? And we only include the significant digits that are those scientific notations. Okay. Is there any other examples that you would like to go over before we move on to calculation parts of this? Good? All right. I know it might take some time to master it, okay? That's fine, okay? I'm patient, and I'll be patient with you as you're learning this. All right, let's go on to your question about addition, okay? Now, when you're adding numbers that are actual measurements, okay? Actual measurements. This rule also applies to subtraction. So whether I'm adding or subtracting. So if you have your calculator, you might want to follow along with me. I'm going to pull out my calculator. Because what I'm going to do is I'm just going to randomly put up some, some possible example problems of addition and subtraction. And we can just kind of play around with this a little bit, okay? For a moment. So let's say I'm going to just start out easy, add two numbers together. So if I have like 26.07 and I'm going to do 10.13. Okay, so we'll do something really easy. Well, actually, let's do this. Make it that. That'll make it more clear what we're doing here. All right, now, first of all, to add measurements, the units have to be the same. Same thing with subtraction, okay? You can never add or subtract different units, okay? Is everyone clear on that? Okay, so the units must be identical. If the units are not identical, you can't do the problem, or you're gonna have to do some conversion of one unit or another, okay? So in this case, all I'm gonna do is add what? 36.17, okay? So that's my normal addition problem. The question is this really the correct answer for a calculation of measurements? Okay, you're saying no, no, okay? What's the real correct answer? 36.2, fantastic. That is correct. Why?
One number after the decimal, so you need to make sure the answer will be one number after the decimal.
Good, okay. Sort of what you can think of with addition and subtraction is that you find, you look at the measurement that has the least number of decimal places. The smallest number of decimal places, least number. Smaller, least, whatever. This one has 2 decimal places, right? The second one has 1 decimal place, okay? What that means is that that 1 is really an uncertain digit. We don't know for certain if this 1 is really a 1 because we're guessing here, okay? In the in the measurement above, we're guessing the 7. We believe that 0 is a certain digit, but the 7 is uncertain. So if I add these two together, basically we're saying that these two digits are uncertain. We don't know if this is really a 1 and that's really a 7. So the problem is we can't have more than 1 uncertain digit. Okay? So therefore, you must round at the point 1. In other words, clarifying that down, find the measurement that has the least number of decimal places, and that is the number of decimal places that can be in your final answer. The least number of decimal points is 1, therefore 1 decimal place. Clear on that? Even if you're adding multiple measurements, find the one that has the smallest number of decimals. Let's do another example here. Let's say we have 100.1, we have 10.67, we have 200 point, I don't know, 3, okay? We'll add them all up. So what is that? 7, that's what, 9, 10, that's 1, 1, and 3, okay? With our decimal point. Now, the question is, again, is that the correct number of significant digits? No. Where do I need to round at? To the 10th place, right there, right? That should be my last digit. So I'm going to round to 311.1, okay? Again, because this is the least number of decimal places, these two, okay? And therefore, I'm going to round at that point. Okay, does that make sense? Everyone clear on that? Okay, let's do one more. Let's do something like this. This sometimes will give students a pause to think about here. So let's say I'm doing, let's go with 200. Let's go with 30.4. Let's go with 20.567. Okay, these are all, we'll say, centimeters. So they're all the same unit. Okay, so we add them up. We go what? 250.967 centimeters. Okay. Okay. No, what's wrong? 251 centimeters. Do we have a consensus? Is that correct? Wonderful. You guys are great. That's exactly right. Right? 200, there are no decimal places, right? So 200 is the least number of decimal points. We can't have any decimal places in my final answer in this particular problem. Okay? Because the least number, or the smallest number of decimal points is 0 in this case. Or no. Yes or no? Fantastic. Okay. Now this works same thing for subtraction. So subtraction, addition, same idea. Go by decimal place. Now let's do multiplication. I think multiplication and division are easier to understand. So let's do something like 27.0, and we're going to multiply that by, let's say, 2.46. Okay. So if I was to just, I'm going to use my calculator on this one. If I was to multiply this, what? 27 times 2.46 would be 66.42, okay? Now, if these are meters, my answer should be squared meters, right? Okay. But the question is that the correct number of significant digits? The answer is no, okay? Now, what you got to do with multiplication is you got to determine which of these overall has the smallest total number of significant figures. So now we're not caring about the decimal place. What we're caring about is the total number of significant figures. So how many significant figures does this top value have? 3. Okay. How many does the bottom one? 3. Which one has the smallest number? Both. They're both what? 3. So how many can I have my final answer then? Only 3. Okay, only 3 significant figures. So my answer needs to be 66.4 square meters. Okay, that's the correct answer. 3 significant figures, 3 significant figures. Okay. Okay, so now let's do something like let's go 200.76. We're going to multiply that by 40.936. Okay. Now, right away, you should be able to tell me how many significant figures is going to be my final answer. 5. Here's 3. How many significant figures are in this top measurement? 5. How many are in the bottom one? 6. So which one's the least number? 5. So automatically, without even doing the calculation, I should only have 5 significant figures in my final answer. So if I do that, 200.76 multiply it by 40.9367, I get 8218.4518292. Have you ever been in your math classes and go, holy crap, how many decimal places do I actually have to write? Do I have to write out these 10 decimal points? The answer is no, not really. If they're measurements, no, absolutely not. You have to write according to the correct number of significant figures. You can have 5, so these are 4, so we round to that point. So 8218.5, whatever our unit is, we'll say it's meters squared. And there we go.
You always round up on 5.
Thank you. For this class, there's different ways to round, right? For this class, for AP, they're good. If you're at a 5, you're going to round up. Okay? If you're below a 5, just keep it. Okay? We're keeping a very simple rounding system. Okay? AP is good with that. Good?
Based on like what you said before, for like the like how you want us to turn in the assignment, like.
Okay, I'll clarify that. So every unit, you're going to be giving a variety of problem sets. Okay, I think for this unit, you're going to have like 6. Okay, so all 6 problem sets you will do through the course of the unit. On the day of the test, you will actually submit your work to me. That's correct. Does that make sense? Okay. Labs and stuff you'll submit prior, but homework assignments, I don't want them turned in because I want you to use them as a tool to prepare for the test. So what we'll end up doing is you will do the problem set. I will give you a due date because that's the date that I'd like to go over the answers in class, or go over and ask, or answer questions. Okay. Again, we don't grade homework. Homework is here for for you to practice. It's like a sport or a musical instrument or something like that, where you spend your time practicing for that big concert day, right? In chemistry, we do the same thing. We practice, that's your homework. Practice for that perfection. And then you have your show day, the big day, which is the test day. That's right. So this problem set number 1, I will never see again. You will just submit your answers on a separate sheet of paper, and you will have, so basically on the day of the test, you'll just staple all of your problem set sheets, answers together, staple them, and then you'll turn it in as a package deal. Okay? Good? Okay, great question. Now, if it's something like this, you don't have to show me the work. You can just show me your answer to the correct significant figures with the correct unit, okay? If there is a unit, okay? If it's a more complex type of chemistry problem that we will be getting into in some days from now, you will show me how you solved it, your work, and so forth. Especially if there's an equation involved. There's equations involved, I want to see your work with that. Question? Oh, does that make sense? Is that clear on that? Okay. I'm glad we were able to clarify that. All right. As far as this is concerned, so how are we doing? Okay, I'm going to give you one more problem, and then we're going to move on with today. Okay? Okay, let's do a division problem. So let's say we have something like 0.0462, and we're going to grams. We're going to divide this by say 0.0 let's do 9 4 milliliters. Let's just do it that way. Okay, so let's just divide that out. So 0.0462 divided by 0.094. And again, I'm going to get a bunch of decimal places, 0.491489361. Okay? Do I really need all of those decimal places? No. How many do I really need? 3, 2, here in 3 and 2. How many are up here? 3. How many are down here? 2. Which is the smallest? 2. So I only need 0.49, and the units would be grams per milliliter. Agreed? Okay, so these zeros are not significant. They don't count. Okay, so at 2 significant figures, that will determine the total number of significant figures. All right, before we move on, I want to give you an opportunity to ask if there's a specific type of problem or example you want me to run through. Go ahead. What do you think? If these were both grams, what would be the final unit? That's right. So there would be no unit. It would be unitless. Okay? When you divide two variables that are the same, they cancel out. Just like if you had x divided by x, right? Which is really what? 1. Okay, hold on. Let me write this down. All right, what's the first one? 1.6.
Kilometers.
Oh, I was gonna fix a couple of things for you on that. Thank you for bringing that up, Luke. I need to correct a couple of units that are on there. Okay, so let's go. So 1.6 plus 1.62,
1,200.
1,200. 1,200, like that. Okay. And these are all what units? Okay, that's the unit one, okay? So what I want you to do is convert them all to, or just keep them all meters, okay? That's a typo. They should be all meters. Okay, so just change those units. That's one of the ones I was gonna have you change. They should be in meters. No, because if it's in kilograms, you're gonna have, well, so, oh yeah, that one? Okay, those ones, of course, you can't add, right? Because they have different units. Okay, so you can add those. Okay, makes sense? They have to have the same unit in order to add or subtract. If it doesn't have the unit, the same unit, you can't do the problem. Okay? Yeah, so if you have a length unit and a mass unit, and you're trying to add a length unit and a mass unit together, you can't do it. Won't work. It's mathematically incorrect. No answer. You can't add, right? You can't add them. So these should be meters. Does that mean, are we okay? We can finish this up really quick. So let's do that. This was just 1,200, right? Okay. So if I go 1.6 plus 1.62 plus 1,200, then I get 3.22 meters. Okay. Well, we have to go by decimal places, right? Which one has the smallest number of decimal places? The 1,200, right? With 0 decimal places. So I have to drop that. So it's going to be 1,203 meters. That should be my absolute final answer for that problem. Okay. Good. Okay. That was the problem we needed to correct the units on. Let me grab a problem set so I can see. Oh, that'd be easier. So number 4. Go to the next page. Number 4 what? Oh. Okay. Okay. So number 4, you're talking about the 65. Okay. Great question. Now, Europeans, I don't know if you've ever been to Europe before. Europeans do not use decimal places. Okay? What they do, or sorry, I meant commas, not decimal places. What Europeans do is they put a space separation instead of commas. So 65 with a 000, for us, there should be a comma there. Okay? So whenever you have like a digit that's kind of missing, and you're like, well, wait, there's a space there. What's going on? It just means that there really should be a comma there. Okay? So many scientists write in that term. Okay? They've kind of kept the European style, and a lot of times you won't see commas. The reason for that is because sometimes people, when they type, the comma and the period are sometimes, I don't know, like confusing, I guess you could say, or if we get too many commas. So they just basically stick to the decimal place, space with no commas. Okay? Number 1, F. Oh, shoot. Okay, let me fix that really quick. This is also with E. So number 1E should be in scientific notations of 4.6 times 10 to the 5th meters. That should be to the 5th power. Sometimes the computer does that, and I hate that when it prints that way. Okay, and then so number 1F should be 4.06 times 10 to the minus 5 meters. And I think the rest are okay. Okay, good. Thank you for bringing those up. All right, we all good now? Sweetness. So let's do our lab. Okay. So I'm going to end this.